In this video, I'm going to walk you through the first lab, step by step. So the goal of this lab is not so much to build something big or complex, but just for you to work through all the tools and get all of the pieces put together. And then in the next two labs, we're going to build on this and the skills that you learn in this video to implement some cool digital circuits that actually perform math. So for this lab, we're going to implement an AND gate on the FPGA. So the UPduino 3.0 has this chip here that is a field programmable gate array. We'll just use the term FPGA, which means that it has this huge collection of logic gates built into it, and we can configure the wiring of all those logic gates internally. We'll discuss in more detail exactly how that works in a few weeks. So I've got two switches here, and when I press one or the other, nothing happens. But when I press both of them, the LED lights up. Here's the circuit we're going to use. If you're already pretty confident in your ability to wire up a circuit from a schematic, feel free to skip the next few minutes of the video and just wire this up. Okay, so we've got our UPduino, and we are going to implement an AND gate in logic inside the UPduino. So here's our AND gate, and the two inputs to the AND gate are going to be input pins on the UPduino. So most of these pins, any of these numbered pins here, can be inputs or outputs. And so we'll have two of those set up as inputs, and then one of them set up as an output. And we have to pick which particular ones we use. So maybe let's just use the ones here on the end. So 28 and 38 here will be our inputs, and 2 will be our output. So 28 and 38 over here, and 2 will be our output there. Okay, on the output, we're going to want to connect an LED. So we'll go ahead and wire up the LED like that. And then the other end of the LED is going to need to connect to ground, so to the 0 volt reference, so that when pin 2 goes high, current is going to flow from the high part, from the pin, out down to the 0 volt reference. But we can't just connect it directly to the reference. We need to make sure we use a current limiting resistor so that we don't burn out the LED. So we're going to put a resistor in here, and then to ground. And we want a fairly small resistor. We don't want to limit the current too much, so we're going to use 330 ohms. So those are the resistors that are orange, orange, brown, and then the gold stripe. Or if you look at it this way, if you put the gold stripe on the right and read from left to right, it's orange, orange, brown. So 330 ohms. Okay, then ground itself, of course, this actually has to be a real circuit, meaning the current actually flows completely in a loop. So the ground is actually connected to the ground pin on the UPduino. There's actually 3 of them. So there's a ground pin here, and a ground pin here on the end, and then a ground pin on the other side. So when we go to hook it up, we'll make sure we do that. Okay, now we need to connect the 2 buttons on the input side. So the buttons are going to be a closed circuit when you push the button. So when the circuit closes, we want that to be a high value. So when I push the button, that gives us high voltage or a 1. So we're going to connect a 3.3 volt signal here through the switch to that pin. And then we'll do the same thing with pin 38. So we'll have 3.3 volts here. And I'm using 3.3 volts because that's the standard high voltage for the UPduino. So you'll see different microcontrollers and different FPGAs use different voltages. 5 volts used to be a common standard, and now most things have shifted towards 3.3 volts. Even smaller microcontrollers will often use 2 volts or even 1.2 volts. Okay, so we've got these 2 switches, and when the switch gets pushed, then one of the inputs or the other input or both will get connected to the 3.3 volts. The problem is, what happens if the switches aren't connected to anything? If we disconnect the switch, we're not pushing it, then this wire here is just floating. Now you might think, oh, well, that just means it's a 0 volts. But that's not true. There could be some electrical charge here, and that electrical charge doesn't go away unless we give it a place to go. And so what we need to do is add a pull-down resistor that gives that any charge a place to go and defines a definite reference here. So we're going to add a resistor and then connect it to ground. And here we want a pretty big resistor, so we'll use 10K ohms. So that are these brown, black, orange, and then again the gold here. And we'll do the same thing over here. Okay, again, remember that the ground here is actually connecting to one of the ground pins on the UPduino, so maybe just to make that clear, we'll do this. So we've got ground here, and then likewise the 3.3 volts is coming from the UPduino. So right next to the ground pin here is the 3.3 volt pin. So the 3.3 volts is, and the pin is labeled 3V3. Okay, so that's our complete circuit, and now it's time to wire it up. So if you haven't used a breadboard before, the important thing to know is that each column of holes here, or each row depending on how you've oriented it, but each column, the way I'm showing it, is electrically connected together. So these 5 holes are all electrically connected together, and they're separate from the next row of holes over here. So anything you connect in the same column will be electrically connected together. And large components like the UPduino or other chips are often designed to straddle this gap in the middle so that each of these pins on the UPduino or on whatever chip are in their own column and are not electrically connected to each other. So again, the top column of 5 and the bottom column of 5 are not connected together, which means, for example, that pin 2 and pin 28 are on their own separate columns of 5 pins. Okay, so now we can start making some connections. The other thing to know is that these long rails on the ends, so one's labeled blue and one's labeled red, that doesn't have any electrical significance, but by convention we're going to use the blue one for ground and the red one for power, so for 3.3 volts. That's because oftentimes ground and power need to be distributed to lots of places, and so it's really common to just wire that. So we'll take this to the 3.3 volt pin and we will jump over to the power rail. And now anywhere on this rail we can use to get 3.3 volts. And let's do the same thing with ground. So we'll go from ground and then over and plug that into the ground rail. Again, there's nothing that says you have to do this, but if you don't expect a lot of help from us, from myself and the TAs. Will get really confused when you look at your circuit. So follow the convention and everybody will be much happier. Okay, the next thing we're going to want to do is we've got our switches. So they're going from 3.3 volts, and then they're going to connect through a resistor and then back to ground. And so let's grab a switch. So if you've got your switches on one of these paper tapes, you'll just want to get a pair of wire cutters and clip them off. So you've got your switch like this, and now we can go ahead and plug it in. So one way we could do it is just plug it directly into the 3.3 volt rail, like that, and then into a particular spot. And let's go ahead and do that with the other one. It's going to be a little easier sometimes if you bend the leads out. So let's go ahead and do that. Okay, so we've got our 2 buttons. On one side, those buttons, the switch is connected to 3.3 volts. On the other side, it's not connected to anything yet. Then, so we said on the other side, we're going to connect from a 10K ohm resistor back to ground. So again, we can use the ground rail here. So let's do that. And we'll take our 10K ohm resistors. You can just pull these out pull the paper tape off of them, or if you want to clip them shorter with the wire cutters, you can do that too. So I'm just going to bend them And so we're going to go from the same point, or from the next point in that same column, and then go back to the ground rail. Okay, and let's do the same thing on the other one. So again, from the same point to the same column, back to the ground rail. Okay, and now, so that's completed from 3.3 volts through the switch, through the button, through the resistor, and back to ground. So that's this path. Now we need to connect this path from the output of one to pin 38 and the output of the other to pin 28. So we can get a couple more wires. Let me grab this brown wire. Again, anywhere in this column, so I've got 3 more places to choose from. I'll go ahead and put that in 28. And anywhere in this column, and I can go ahead and put that in 38 right next to it. Okay, so that completes this side of the circuit. And now we're ready to go ahead and and we've already done the 3 volts connection and the ground connection to the UPduino. So now we just need the LED and the resistor. Okay, so the LED is going from pin 2 through the LED, through the resistor to ground. And the important thing to know about LEDs is that it does matter what direction they go in. So the switches, they're just making or breaking an electrical connection. It doesn't matter which way they go. Resistors likewise operate the same way, regardless of which direction they are. But LEDs are different. And so you'll notice in the schematic, with the way we've drawn it, there's this triangle and then a flat edge. That's the direction that current has to flow. And if you look at an LED, you'll see that one lead is shorter than the other. So the shorter lead is the side that's closer to ground, the negative side. The longer lead is going to be the positive side. And if you look at it, you can see that this side is flat. So it's often difficult to see on such a small LED as this. But if you feel around with your fingers, you'll often be able to feel that flat side, which again corresponds to the shorter lead, and the negative side. Okay, so I like to bend my LEDs just using 2 fingers like that. And that gets the leads about the same length here, and then nicely spaces the leads apart. Okay, so again, the longer lead is going to be coming out of the pin. Then the shorter lead can then plug into some other row here, some other column. Okay, and then finally we need the 330 ohm resistor. So that, again, it's orange, orange, brown. We can go ahead and bend that one over and connect it, again, in that same column and then to ground here. But again, this ground rail we haven't connected to anything yet. So finally we need to connect the ground rail to ground. So we could either connect it over here, connect this ground rail to here like this, or what we could do is use one of these other ground pins, so the ground pin here, and connect that on that side. Okay, now we've wired up the whole circuit, and the next thing we're going to have to do is program the FPGA to implement this AND gate inside there. The first thing to do is to start up the ES4 Lab virtual machine. This is a pre-built Linux image which already has all the tools you're going to need for the semester. So if you haven't already set this up, go check the course website for details about how to do that for your operating system. It'll run on Windows, Mac, and Linux. Makes things a lot easier. If you really want to do things the hard way, you can install icestudio directly on your computer. But unfortunately, Radiant you won't be able to install on a Mac. So I do suggest you go ahead and do this. Set up the virtual machine now rather than later. Okay, with the virtual machine running, we can go ahead and launch icestudio. And this is a tool we'll be using for the first couple of labs. You may get this authentication required pop-up. This is just because it's logging in automatically, and so you didn't have to enter your password there. So go ahead and put in the password. Again, that's the same as the login password in the installation document. Okay, now we have an icestudio window. So now we've got this blank project that we can go ahead and start working in. I've already configured it, so it should be selecting the UPduino 3.0 by default. The toolchain should already be installed and ready to go. So let's go ahead and add an input. Where it says enter the input blocks, this is just a name for whatever we'll call it. So we'll call it A, and it's an FPGA pin, of course. There's A. And let's pick another input. We'll call that one B. And now we've got to pick the pins that these are going to be selected on. So we said we're going to use pins 28 and 38. So let's find GPIO 28. There it is. And for B, GPIO 38. And then we'll need our output. So we'll call that LED. And we've connected our LED to pin 2. So you'll notice that there already is some things called LED green, red, and blue. That's for that built-in LED on the board. You can use that if you'd like, or play with that additionally, but go ahead and use the external LED for now. So that's GPIO 2, and here we go. Okay, now in the logic, we can pick any of the different kinds of gates. So let's grab an AND gate, and we will just drop that in here, and then wire it up. So you'll click on the source, and then just drag it to wherever the destination connection is, and then the wires should stay connected once you drag things around. And again, drag source to destination. Okay, at this point, we've completed our AND gate design. So we've got 2 inputs, take the AND of those, and that will drive the output. And so let's go ahead and try to run it on the FPGA. So first you want to verify, make sure that there's no errors in the design. And if you get this green verification done, then you're in good shape. Then we'll build it. So this actually compiles the design for the bit format that needs to be packed on to the FPGA. And this takes a few seconds. So if you're used to software code that happens almost instantaneously, what's happening here is actually pretty complex. And so even for simple designs, it does take a few seconds. So after successfully building, you can go ahead and upload to the FPGA. So you'll need to plug in the FPGA with the USB cable, and then everything should connect automatically, and you can just click upload. This will take a few seconds. It first has to erase everything in the FPGA and then upload the new image. If it's taking longer than 15 or 20 seconds though, then that's a problem. Okay, so the upload just finished, and so now we can test it out. If you do have problems with the upload, there's a couple things you could do to start troubleshooting. The first is to make sure that the virtual machine is actually connecting to your USB device. So if you go into the devices menu, sometimes this will be at the top if you're not in full screen mode. Go to USB, and you should see tinyvision.ai UPduino 3.0 somewhere in this menu, and that box should be checked. So if it's not checked, then you should be able to just click on it, and then that will connect it to the virtual machine. If it's not there at all, then that means that you're probably not plugged in, or there's some problem with the host machine even seeing the USB device at all. And then if that is checked, but you're still getting errors, another thing you can do is open up a terminal, and inside that terminal type ls USB. So that will list all of the USB devices that the virtual machine thinks it has connected to it. And one of those should be this device here, Future Technology Devices International USB UART FIFO IC. And if you don't see anything like that, so if I actually unplug my UPduino and then try it again, if you just get these devices and you don't have anything from FTDI, then there's a problem there with the guest operating system, with the virtual machine recognizing it. Post a question or reach out to the teaching staff and we'll try to help you through that. So let's test this. I've got my USB cable plugged in now, and if I press one of the buttons, nothing happens. If I press the other button, still nothing happens. Then when I press both, the LED should light up. And in fact, it does. So the circuit is working. If your circuit's not working, then you're not able to get that LED to light up when you press both buttons, or maybe it lights up when only one of the buttons is pushed. The first thing you want to do is go and check that these get a multimeter if you have one. We've got access to multimeters in the lab, and confirm that the value on the inputs actually is toggling between ground and 3.3 volts like you would expect. You could even try creating a simpler circuit in icestudio where you just connect the input directly to the output and confirm that one of the buttons is able to toggle the LED on and off. And finally, you might confirm with a multimeter that the output is toggling high and low, and you might, again, check that the LED is put in the correct way, and so forth. In general, it doesn't help to just rip everything out and start over, or just to try random stuff and hope that you'll find the right solution. The best way is to break it down and figure out what you expect at each part of the circuit and check that with some kind of instrument. So obviously a multimeter helps, but you can even use an LED to poke around and examine whether a particular point is high or low. When you're all done, just check in with your TA and demonstrate that your circuit is actually working. You're also welcome to go ahead and get started on the next lab. There's nothing to stop you. And we'll start building more interesting circuits, building multipliers and adders and things like that. So good luck.